bit in the hopes that you were working. So here we go. If I want to multiply, this is going to give me x squared, and I'm going to do the FOIL in my head. So it's going to be negative 2x minus 1x, which is minus 3x plus 2 times the x minus 3. Then I'm going to use the distributive property, and I'm going to use my math. See, math makes me so happy. That's all I need is just do math, and then I'm happy. So I'm going to take the trinomial times the x, and then the trinomial times the minus 3. Now I'm in my happy place. So I'm going to get x cubed minus 3x squared plus 2x. Then I have minus 3x squared plus 9x minus 6. Double check that. And then I'm going to collect my like terms and get x cubed minus 6x squared plus 11x minus 6. How about thumbs up? We got it? Remember how to do this, all right? So what's really cool is everything you've been learning we're going to draw from, okay? So we're drawing from this skill. All right, so now we're going to go back to 4th or 5th grade, okay? We're going to go back to 4th or 5th grade, and we are going to review long division. Now, it's my understanding that sometimes they teach you a different way than really what high school would prefer, and that's okay. So I'm going to go through this the way that's going to help us with what we're going to do today called polynomial long division. I do not know why I made such a big bar there. Okay, so let's review. I'm not using a calculator. Exactly. And so if I want to divide, what you do is you kind of say this. My divisor, okay, 28 is the divisor. Let's write that down. 28 is called the divisor. And the divisor is what you're dividing by. Let me say that again. The number that you divide by is called the divisor. The answer to a division problem is called the quotient. The dividend is what's being divided, and your remainder is what's left over. So I'm going to be using some vocabulary here back from 4th and 5th grade, and I know that some of you are 10th and some 11th, and I think we even have a 9th grader. So, this could be 4 or 5 years ago that you did this, so we'll gently try to refresh memories here. So what you divide by is called the divisor. The answer to a division problem is called the quotient. The dividend. So in this problem in the launch, what's the dividend? Good job, 4,089. That's the dividend. All right, so when you're doing a division problem, you start with the divisor, 28, and you say, does 28 go into 4? No. And then you move like the decimal over a little, and you say, does 28 go into 40? Yes. How many whole times does 28 go into 40? Just one whole time. So then we multiply, right? 28 times 1 is 28. And then what did you do in the long division process? Subtract, okay? And 40 divided by 28 is 12. And then do you remember you brought down the next number? Now I'm going to ask myself, 28 goes into 128 how many whole times? Now if you're not touching a calculator, we're going to play with our fingers here, is 128, or 28, excuse me, the divisor 28 is pretty close to 30, right? So if I go 30, 60, 90, 120, right? So let's try 4 times. And I'll do 4 times 8 is 32, carry the 3, 4 times 8, or 4 times 2 is 8, 9, 10, 11. Ooh, that worked out good. good. And then we subtract. And then you bring down the next number. So let's try that again. 30, 60, 90, 120, 150. Go there 5 times, or is it going to be more than that? You think 6 times, right? Yeah, I'm thinking 6. So this will be 48, carry the 4. Yeah, ooh, yeah, that one is nice. But do you see, I mean, I could get a decent approximation. So back in 4th grade, when you first learned how to do this, you wrote it like this. And you said the answer, the quotient, which is the answer, would be 146, and we did R1. That was 4th grade. Then in 5th grade, you learned this. You went up a little bit in level, and you said, really, though, this is 146 plus 1 over 28. You took the remainder over the divisor. Okay? So long division leads to this result, and I'd like you to use your highlighter here, and let's highlight this piece that says, when you have a dividend over the divisor, you get a quotient plus the remainder over the divisor. So we're going to now take this to polynomials. Okay, now we're going to take this up to algebra 2. And the really cool thing is, I've been using polynomial long division in AP Calculus this unit. So it does get used again later beyond what we're doing, but it does get used in advanced math. So the learning target is I can divide polynomials using long division. So today the goal is to introduce it and practice, and after tomorrow we'll sort of master it, okay? So to suppose you're given the graph of f of x equals 6x cubed minus 19x squared plus 16x minus 4. So do you see my end behavior? I have my end behavior. And I have that there is a 0 at x equals 2. But I don't know exactly what that other 0 is. It's not crossing at 1. It's not quite at a half. So because x equals 2 is a 0, what is a factor then? What do I know is a factor? So x equals 2 is a 0, then what is a factor? What could I, like if I were trying to write the equation, what can I write down from x equals 2? Good job. I would write x minus 2. So this means that there is some second degree polynomial, I'll call it q of x, such that, and I want you to use a highlighter, that f of x, I could rewrite it as x minus 2 times the q of x. To find that, we're going to have to use polynomial long division. Okay, so we're going to learn this skill. So first of all, who cares? Like, why would we want to know this? Well, electricians can divide polynomials in order to find the voltage in an electrical system. Now, it'd probably be electrical engineers. I'm not sure that actual electricians do that, but electrical engineers can do that. Engineers can often use polynomials to model the path of a roller coaster. That's super fun. If we can find a line that just touches a graph at a point, we can estimate the speed of the roller coaster at that moment in time. So there's some real world connections to polynomials. So here's the process. And I wrote it out for you, and then we're going to do 4 problems. So we're going to work nice and slowly here. Step 1, take the first terms in each location and divide them. So we're going to do example 1 as we work through these. So my first terms are x squared and x. So I divide them, and you're going to put that answer above its like terms. So here's what I mean. So we're going to take x plus 1 is going into x squared minus 9x minus 10. So you take the first terms, x squared, and divide by x. And I'm going to use different colors because this can get really confusing. Okay, so if you're a little bit behind me, you can get lost in what I'm doing. So I'm going to try to pause, go slowly, repeat myself. So watch this. I'm going to put the x above the like term. You see where the minus 9x is? So I put it up here. Now let's go scroll back a moment. And you remember when we did this, we took the 1 times the 28. So I'm going to take the x, but I'm going to distribute it across the x plus 1. And then line up those terms with their like terms. It doesn't necessarily go in order. It goes underneath the like terms. So let me repeat this before I continue. So you're going to set up a division problem. Okay, my divisor is the x plus 1, so the divisor goes on the outside. My dividend is the x squared minus 9x minus 10. That goes underneath the division bar, the division symbol. And then you take the first terms and divide them. So then I put that x up at the top, and then I'm multiplying, just like I did with basic long division. Now here's the tricky part. Now, do you remember what we did? Once we put 28 down, we subtracted, right? So I have to subtract. The technique I prefer, and you don't have to do it this way, so, and let me mention before I continue, these numbers or these terms have to match. If they don't, you made a mistake. Because the goal is I'm going to go through and eliminate the first ones and then repeat, repeat, repeat. So what I do is instead of literally subtracting, I add the opposite. And so do you remember A minus B is A plus the opposite of B? Do you remember that from pre-algebra? So watch what I'm going to do. I'm going to take the opposite and then add the column instead of subtracting because it's the same thing. So the x squareds cancel and I get negative 9x plus negative 1x, which is negative 10x. And then I repeat. I take negative 10x divided by x. So I'm taking the first term now divided by the first term here. I'm going to change color so now you can, whoops, let me finish that one. So negative 10x divided by x is negative 10. And so I'm going to put a minus 10 here. And then I multiply. So that's a negative 10x minus 10. I take the opposite and subtract. So my remainder was 0, which is nice. So my answer to the division is x minus 10. And what's interesting, yeah. We're going to do one. I'll let you know. And actually, it's just like up here. Do you remember where I did the remainder was 1? And we're going to do 1 over the divisor. Like, so you'll take the remainder plus the remainder over the divisor. But here's something I want to pause and think about. Because the remainder was 0, do you see if I took x minus 10 times x plus 1, it multiplies to the dividend. And if I had a remainder, I would still multiply and then add the remainder, and it should then equal the dividend. All right, so again, I don't expect you to fully understand what we're doing yet. This is going to take a little bit of practice. So let's try the next one. And when you sit there feeling confused, I need you to remind yourself and say, this is actually, I'm learning something new, and I'm learning something complicated, and Mrs. McInerney believes in me and knows I can figure this out. Eventually, it's okay if I don't get it yet. We're going to take our time and figure it out together. And again, I'm trying to go nice and slowly here. So watch what we're going to do. We're going to take the first terms. So that would be x to the 4th divided by x, and that's x cubed. And then, I mean, can you see, this is like so amazing to me. that this is now, I see my Algebra 1 purpose when I did exponent properties. Oh, okay, I didn't realize when I did polynomial long division, I was going to have to know x to the fourth over x to the first. I have to subtract the exponents. Like, so sometimes you have to wait to find this stuff out. So I'm going to put an x to the third up here, and then I'm going to distribute. I'm going to multiply it by the x and the minus 8, and then line it up where it would go. So this is going to give me x to the fourth minus 8x cubed. Now, if you don't want to do the opposite and add, you are welcome to subtract. My experience has been students make sign mistakes with this. And that's the other thing is, I am not going to give you problems that don't work out. And so here's a helpful suggestion. If you're getting it where it's going to be, I have to multiply by 2/5 or something, you've just made a mistake. Like if they're not going in nicely, you've just made a mistake somewhere, okay? All right, so now I'm going to add the opposite. So I'm going to take the opposites and add. So my x to the fourth cancels, and then I would get negative 9x cubed plus 81x squared, and I personally just bring them all down, just like we did before. And if you get this, then it's just repeat, 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 repeat until you can't go anymore. So I'm going to change colors. Yeah, Angela? Okay, so do you see this was an x and this is my x. This is x cubed, this is x cubed. That's what I meant by putting it by its like term. What do you mean 8 minus x? Here. That's why we're doing this. This is where that comes from. If you want to know x to the fourth divided by x is what? That's the first one. So I did x squared divided by x is x. And we'll eventually see numbers in front. Eventually. I tried to keep them easier to get started. So I'm going to now take negative 9x cubed divided by x. So you're taking this first term that I now have as first divided by this first term. So then that's going to give me what? Negative 9x squared. So I'm going to put a minus 9x squared. Then I'm going to distribute that and get negative 9x cubed plus 72x squared. Yeah, Davey? Okay, I took the minus 9x squared and I distributed it across the x and the minus 8. Yes. All right, let me change colors and I'm going to take the opposite and add. So that's actually going to give me 9x squared, and then I bring down the other terms. So when I add the opposite, the negative 9x cubed and the plus 9x cubed, they cancel, which is what I wanted. All right, now I'm going to take that first term, 9x squared over x, and I get 9x. So I put it up at the top and make sure you put a positive because that means addition between those terms. Then I'm going to distribute and I get 9x squared minus 72x. All right, now I'm going to take the opposite and add. This is the part where if you're behind me and then you don't see that I did the opposite, and you're like, where did that plus come from? You know, it's like, well, I took the opposite. And I'm trying to use different colors so you can see it. So that's what? 7x minus 56. Then I take 7x over x, which is a positive 7, so I'm going to put a plus 7. And that's 7x minus 56, which is remainder 0. So my answer, and I'm going to erase this in a moment, the answer is x cubed minus 9x squared plus 9x plus 7. And there's no remainder on those first two. Kind of tried to start us gently with no remainders, and then we'll build into our remainders. Whew, okay, yeah. The 72x came from when I did the 9 times 8. So when I do this up here, I'm distributing it to both the x and the minus 8. So that's why, do you notice every time I had two terms? It's because whatever I had here, I took times the x and the minus 8. So when I got to the 72x, that was 9x times x, was the 9x squared. And then 9x times minus 8 was the minus 72x. So you are distributing. Great question. All right, let's try example 3. Let's try and make this a little bit more interesting. So here we go. 2x plus 1 into, what do you notice? What's different about this one than the other ones, Davey? You understand there's no x squared, right? There's no x squared. So I did this one intentionally because sometimes this happens. In the dividend, okay, the number that's getting divided or the polynomial that's getting divided, if that dividend is missing a term, you have to insert a 0. I did not say divisor, okay, not the divisor, but if the dividend has a missing term, we have to add it in with a 0. That's where it went. Okay, so here we go. I'm going to take 8x cubed over 2x, which is 4x squared. So, do you see, I needed that to put my 4x squared here. And then I'm distributing the 4x squared across the 2x and the plus 1. So this is giving me 8x cubed plus 4x squared. This is why you need to put the placeholder. It's so that you can see where the 4x squared lines up. If you don't, then it has no place to subtract. All right, I'm going to take the opposite and add. So the 8x cubes cancel, but then I get negative 4x squared plus 14x plus 8. Then all I'm doing is I'm just repeating. Once you get this step down, then you can do the whole process. You just repeat, 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 repeat. Yeah. Lilia? Okay, do you see that when I distributed, I had a 4x squared, but there was no x squared like term position. So I need to make a position, and what happened to it is its coefficient was 0. Because 0 times x squared is what? Is 0, right? So that's what happened to it. So, but I needed a place to combine with my 4x squared. Great question, though. All right, so I have negative 4x squared over 2x. So what would that be? Negative 2x. So I'm going to put the negative 2x up here. And let's distribute. So that's negative 4x squared minus 2x. All right, so I need to subtract. And you either literally subtract or you're going to do my method, which is take the opposite and add. And I get 16x plus 8. And then I just repeat my process. 16x over 2x, which is just the number 8. So then this is going to put a plus 8 up here. And I distribute that 16x. Ooh. This one was no remainder again. No. I was trying to make it a remainder, so I didn't. Okay, so that's all right. So that's 4x squared minus 2x plus 8. No, I meant for that to be, yeah, okay, that's fine. All right, let's do example 4, and I'm going to start to go a little bit faster now. Yeah. Yeah. Do you see where the negative 2x came from? Yes. Over here. Okay, so the first thing I'm doing is I'm multiplying. So I had a negative 4x squared minus 2x, correct? So what I'm doing is I'm subtracting. So negative 4x squared minus a negative 4x squared becomes a plus, right? So when you subtract your quantity, you're taking the opposite of whatever that is. So then those canceled, and then 14x minus a negative 2x becomes a plus 2x. So what I'm doing is I'm just taking the opposite and adding, or you can literally subtract. You choose. But don't mix up the two. Okay? All right, let's try it again. So here we go. I've got x squared minus 5. I have 2x cubed minus 6x squared plus 5x minus 20. I personally enjoy polynomial long division. I think it's fun. It's another math teacher. So I'm going to take 2x cubed over x squared. So what's going to be the first thing above my division symbol, baby? 2x. Nice job. So I'm going to put it all the way over here. Now, this one's good for two reasons. I'm going to have a remainder, and do you see my divisor had x squared minus 5? I don't need to put a 0x in there. That's the divisor. I don't need zeros in the divisor. But watch what's going to happen. This is going to give me 2x cubed, and then I didn't get an x squared. So I don't put the minus 10x under the 6x squared. It lines up with its like terms. Okay, that's what I was saying, but we didn't see one. All right, so now I'm going to subtract. So for me, I'm going to take the opposite and add. Uh-oh, look, there was nothing that lined up with that negative 6x squared, so I bring it down. You don't ignore it. There was nothing underneath there to subtract. All right, now I'm going to take negative 6x squared divided by x squared. What would that be? Negative 6, so I'm going to put the minus 6 here, and that's going to be negative 6x squared plus 30. All right, so now I'm going to change colors so we can see it. So I take the opposite and add, and I get a remainder of 15x minus 50. Now I can't go any further, right? Because x squared doesn't go into an x. That's how you know you're done. So now watch how you write your answer. This is our first time, and we'll do this more tomorrow. I'm going to get 2x minus 6 plus. Then you take your remainder over the divisor. So it's your answer. Let's maybe write this down. You take your answer the remainder divided by the divisor. Okay, it's the answer plus the remainder over the divisor. All right, now we're going to connect this back up to the warm-up. In example 5, it says, let's revisit the polynomial below that we knew had x equals 2 is a 0. We can use polynomial long division to find the quotient. So watch this. I'm going to take the factor x minus 2 into 6x cubed minus 19x squared plus 16x minus 4. I'm going to pause for 2 or 3 minutes, and I want to see how far you can get. If you're struggling to get started, you take your first term. So you take 6x cubed divided by x, which is 6x squared. Then you distribute. That's 6x cubed minus 12x squared. How many of you did just this part? Can you give me a thumbs up? Could you do this? Outstanding, okay? That is outstanding. Good job. So now I'm going to take the opposite and add. So I get negative 7x squared. And then you bring down everything else, just like you do with basic long division with numbers. Now that's the process. Like if you get to this, you know the process. The only difficulty most students have is that we make sign mistakes. We make negative mistakes. So I'm going to repeat. Negative 7x squared over x is negative 7x. So that gives me negative 7x squared plus 14x. All right, I'm going to take the opposite and add, or you can just subtract. And then I repeat. 2x over x is 2. So, this is cool, okay? This is really, really cool. What I've just shown you is that 6x cubed minus 19x squared plus 16x minus 4 is actually equal to x minus 2 times 6x squared minus 7x plus 2. So if I want to find the zeros, you set this equal to 0. And unfortunately, so I got my x equals 2, but 6x squared minus 7x plus 2 doesn't factor. Okay, this one does not factor, but guess what? In chapter 5, we practiced quadratic formula, right? So if I want to then find the zeros, so this is why we're doing polynomial long division, is that I don't know how to do it algebraically. By just looking at it, it didn't factor. Like 6x cubed minus 19x squared plus 16x minus 4, it doesn't factor. So if I know one of the zeros, I can take it down to a quadratic, and it'll either factor that way, or I can do quadratic formula. So let's find the other zeros then. That'll be x equals negative b, so that's positive 7, plus or minus square root, negative 7 squared minus 4 times 6 times 2, all over 2 times 6. And just because of time, I'm going to just write it out for you. So these are my other zeros. That's pretty cool business. All right, just because I'm running low on time, in example 6, I'm just going to tell you that the zeros are x's 1, 2, and 3. Okay, just because of time, I'm going to cut to the chase here. If I know the zeros, I know the factors. The factors then are x minus 1, x minus 2, and x minus 3. Well, do you remember our warm-up? I did this on purpose. From the warm-up, we multiplied this out, right? And we got x cubed minus 6x squared plus 11x minus 6. So guess what? If I want to find the other zeros, I could do polynomial long division to take this down from a quintic in x to the 5th Now, what's an x to the 5th divided by an x to the 3rd? Anybody know what that is? If you take x to the 5th over x to the 3rd, it's x to the 2nd, and we can handle any x to the 2nd, okay? And again, just because of time, this ends up being x squared plus 9. Yeah.
So would you still just use the first number to divide?
Yes, yes, you still just do the first, x to the 5th over x to the 3rd. But how does x squared plus 9 factor? This was just on our most recent quiz, right? Or something like it. This factors into x plus 3i and x minus 3i. And so what's really interesting is that if I go look at a graph, you don't see the imaginary solutions because they're imaginary, okay? You don't see those complex solutions. All right, so tonight's homework is the 6-4 worksheet number 1. So go ahead and try it to the best of your ability. I will go ahead and post my solution because I know these are tough. And then tomorrow we'll spend the second day just practicing this, okay? We'll spend a second day just trying to get this down because this is tough, okay? You're in a tough section.